Hey, welcome back. Hope you're all well. Thanks for joining the channel again. Good to see you. Today on my bench I have a little piece of test gear that I picked up for myself. It's something I've always been wanting and been keeping an eye out for one for a long time now. And one finally came across that was really cheap, and I can see why it was such cheap, because it's almost like it was stored in a humid basement. It just stinks with old mold smell, and everything's got that funky, basement smell, and hinges are rusted, everything's rusting. And somebody put this faux vinyl wrap on here. I think I might just remove some of this. It looks pretty bad. If I remove it, oh, see, look at this hinge. It's got a lot, it's stored in a high moisture area, so I'm expecting this probably won't work. But let's have a look at it anyway. Yeah, it stinks. Comes with its tube chart. This is a model 1100, or actually 1100A. Comes with a tube chart. Original one, it looks like. And it looks like maybe all the pages are here, I'm not sure. But that's okay. I can, for these Mercury tube testers, you can go online and you can download the tube charts. And I do have a downloadable one. And but this will be good for quick reference. It's seen better days, that's for sure. Oh, look at this. It has, what is this? Oh, this is out of a television. Picture tube. Here's a high voltage. I don't know what TV this is, but it's not for this thing. Somebody's been changing tubes on televisions. Here's an 11B manual. I wonder where you got this one from. This is an 11A. Consolidated. Let's see what this thing is. Oh, this is tubes. That's what tubes cost back in the day. I don't know what date this is. December 8th of something. $2.97, $3.15, $3.90. They paid tax back then days too. Anything else in here? Oh, this is just an instruction manual. Okay, I remember seeing a schematic. Oh, here it is. Okay, so you have the schematic. This is for the 11B, 1100B. I don't know what difference it is between the A version and the B. I can put the two comparisons and compare them together and do this. If I could find it, I don't know, it's not here. Okay, doesn't matter. I have it on electronic form. So basically all it is AC input, and it has auto transformer, and this selector here selects the filament voltage, switch 5A, and I can't remember which one it is. A 1 milliamp 100 ohm meter movement, and I think I'm gonna have to replace this, and I'll show you here in a bit. And then yeah, it's basically just an emissions tester. It's nothing really more than that, just for checking tubes and to see if they're alive or not. And this is basically what I need for testing some of the old radios that come in here, and I don't have a clue if the tubes are bad or good, so this is why I got it. So we have a grid cap, we got a sketchy power cord. I think I'm going to replace this. It's filthy and it stinks. We have this meter here that has seen better days. This, you can see how the spring tension is on the 0. I think this might be wrong. Let me try adjusting it. Better screwdriver than that. Yeah, I don't know if this meter's any good. It might be, it might not be. This thing is really messed up. It's a little sensitive to the magnetic screwdriver. Anyways, I have a plan for that. For the rest of it, it's just filthy. Let's open it up. I was surprised at how tiny it is too. It's just a little box. I thought it would be, from the pictures on the from the eBay listing, it looked like a lot bigger. Okay, we've got a lot of screws holding this together. Don't know if it works, probably doesn't, but we're going to make sure it does when we're done. Got one up here. No, is that it? Let's have a look at this. And there, it's all point-to-point wiring for all the sockets. There's really not much to it. Some heavy corrosion here. There's a neon bulb, and this kind of looks flaky. No strain relief. That looks really janky. No strain relief. Frayed wires. Corrosion everywhere. This will be a fun one, I think. And it's got a wood box. And did I mention it stinks? My plan is to replace the meter. This is a 1 milliamp meter. And I tried to get the biggest face on it I could find. It looks like a little too big, almost. Let me see how this looks. So 1 milliamp, and it's going to fit right there in the place of the old one. What I'm going to do is I'm going to remove this scale, this meter face. I'm going to scan it into the computer, and then I can reprint it on adhesive back paper, and I can apply it here. Probably have to scale it up a little bit to fit this scale, so I might have to scale it up a few percent to fit this meter, but we can transfer these graphics over onto here, and then we can use this meter in this place, and it should work, hopefully. That's if it's, this is a 1 milliamp. I don't know how many ohms it is. I should check it right now. The original meter was 100 ohms, so let's see what this one says. It's 150 ohms. We might need to work around that. Reverse these. So just for the hell of it, let's try this out. So we have our tube guide here. Okay. And we got some tubes. I don't know what these are. 12AX7, 12AX7, 12AU7, 12AT7, AU7. Let's try an old AU7. These look brand new. I believe they are brand new. 12AX7? 12AU7, okay. Let's look this up. 12AU7. AU7. What is, we got two listings here. So I guess because there's two elements, right? Is that why? Okay. Let's do the first one. 8 F, and there's the filament voltage is F. Z is 7. W is A. Okay. And socket 1. Ooh, that's really loose. Okay, well, let's try plugging this in, see what it does. At 5 watts. Yeah, this is jumping around. I don't think we're getting good connection on any of these pins. Definitely not getting any movement on our needle. Might have to change some of these switches too. I don't think we even have any filament on this. I don't see anything glowing. Alright, so I tightened the pins on those, on that socket. Where did my tube go? Right here. Let's try this again. Seems to fit a little better. Plug it in. We're getting 7 watts now, so that's good. Okay, so this meter is showing it as measuring about 65%. Is that what that means? What does that say? I can't read that. Wow. Seems to be working. Let me see what this switch is. So according to the book, I'm doing everything right. So you press this for quality. So it says press for quality. So when you press this down, it's doing the test. And you're just getting an emissions reading. And it's reading 65%, whatever. So let's set it up for the other element of the tube. And we'll try that one as well. See, it should be about the same. AU7, 6 AU, 12 AU7. So we need this at 3, and this one here at 2. Filament stays the same, weighting stays the same, press the quality, and we're getting about 65% as well. So they're both measuring as a good tube. right on. Let's see if I can find an old used tube. So here's a 6550. It's a power output tube, audio amplifier output tube on a Fender. Is it a Fender? Yeah, it's a Fender amplifier I'm working on. Been working on it for a while now. 6550. Okay, so X is 8. E. 6550. This one goes to 5. And then for weighting, we need A. And it goes into socket 4. Hitting here. Let's let it warm up. It is glowing. And it's starting to come up. %. That's starting to become a theme here. And the needle is just vibrating. I'm wondering if there's a bad cap in there, because there is supposed to be a cap across that meter. Let's see here. It has a 100 microfarad cap across that meter, and it shouldn't be vibrating like that. You can see that on the camera, but it's buzzing. So it looks like it's functioning. Interesting. But really, there's not much that can go wrong with these things. There's, you know, an auto transformer to turn the heater on. There is a voltage that is applied to the, you know, the cathode and the plate, and depending on how much current goes through, depends on how high the needle goes. This weighting thing provides the correct biasing or load. So yeah, and these two switches, they set up the wiring for the sockets. This one sets up the filament voltage. And any shorts, the little neon bulb should come on. This tube looks good. Okay, nice to know. So we just need to clean it up and replace that meter. That meter is really not the best. It's pretty beat up. All right, got the meter removed. Going to remove the face here, the dial, the scale. I guess it's called the scale. Take out these two screws. My magnetic tools don't like this thing. Okay, so what we're going to do is just remove this. Perfect. And it's just aluminum plate with some dead glue on the back. So let's clean this off. I have to clean it with I'm just going to get some glass cleaner on here. Hopefully it doesn't take everything. There we go. Held up pretty good. Okay, what I'm going to do is I'm going to put this on the computer and scan it, and then we can make a transfer decal that we can put onto this one. Alright, so I scan this dial face, or this meter face, meter dial, whatever you want to call it, and I printed it just on plain paper. You can see the resolution is, it's acceptable, but it's, you know, you lose a little bit of resolution every time you do a scan and a print. So, and it looks like we lost a little bit of size too, because if I check this one, from tip to tip, I got probably 69 millimeters, 70 millimeters. If I check this one, we are down to 67 millimeters. So we lost a couple percent on the size. But that's no big deal, because we're going to scale it up anyways when we're done. We need to test fit it to this now. So let's remove the face of this. Okay. Let's remove this dial. Scale. I can find a screwdriver. All I'm looking for here is to see the difference between the two scales, or the two scales, to see how much I have to scale it up. Okay, oops. Don't want to damage the movement. Okay, let's put the cover back on just to protect it. Now, what do we do here? We have to line these up. So what I'm going to do is I'm just going to measure from here, this point to this point, and I get 64 millimeters, okay? If I do the same on this, if I measure from my point that I want, I only get about 59 millimeters. So we need to scale this up from 59 millimeters to 64 millimeters. So you just do the math. Let me do the math here quickly. I'm going to find a calculator. (59 divided by 64). So this is only 92% of what it needs to be, so we need to increase this by 8%. If we can increase this by 8%, we should have a scale that fits this face. So what I'll do is I'll go back to the computer and I'll print off another one 8% bigger, and I'll do a test fit, see how it goes. Alright, so you got to do some fiddling around to get this to fit, because I printed this one 8% bigger, but it's still too small. You can see the difference between the two. One's a little bigger than the other, but not really. So when I'm test fitting this, what I'm doing is I fold it along the original line, the top line here, and just using it as a reference. I'm going with the top of this scale. So we put them on top of each other, and then I line up the zero so the zeros match. It's kind of hard to do because if I had some translucent paper, I could do this a lot easier. I think it's good there, but if I look on the other side, you see we're out quite a bit. We still have a ways to go. So I gotta scale this up again, probably to maybe 12%. And this is trial run fit, and see if we can get it to fit. See, we're pretty, no, not actually, a little bit less. You can see right here we're right on the zero. Here we are off quite a bit. We are off probably 7 or 8. No, probably 3 or 4 divisions here. So we're going to have to scale this up some more. Alright, so I printed this off on sticky paper. It's got one-side adhesive, and I cut it to width. So we have the correct width. Now let's just fold this. I want to fold it along the top line so that we have a reference. Get it on straight. Cut this off too, there's too much of it. Now let's try sticking this down. Let's cut the bottom off. We don't need all this. Okay. Piece it off. Okay, here we go. If we screw it up, we have to go print another one. Yeah, it's a little bit off. Hang on. See if we can get this. Yeah, you know what? It's actually not too bad. There we go. It's on. Dull knife. Well, that didn't work. And there's our dial scale. Let's poke some holes here for the screws. And let's mount this in the meter assembly. All right. Perfect. So I'll make sure the thing engages in the adjustment. Doesn't look like it is. No, it's not. There we go. Okay, 2 screws. We're done. It's a replacement meter. Looks pretty good. So this will get set in place here. I need to drill some more holes Yes, actually it has to go down a bit, probably about 1/4 inch. I have to trim this, so we're going to have to do some metal work to get this to fit in, and it's going to look a lot better. Interestingly enough, this old meter measures 1K almost, well, 976 ohms. It said in the schematic that it was 100 ohms. Huh. It's interesting. I hope this new meter is going to work. It doesn't seem to have the same deflection we were getting. Quite a bit difference here. Alright, before I go any farther, I want to make sure that we are on the same page here with these meters. Now what I've done, I'm just going to do a test. What I've done is I've wired this meter in series with this meter, in series with this meter, and it's in series with a 10K trim pot. And I'm going to feed the whole thing with power supply 2.2 volts just to get the current flowing. And when I start cranking up the current on the trim pot, we should have the same reading. Well, all three of these should match, and we just want to measure accuracy here. I have a feeling this meter, this old one, is probably way out of spec. So let's turn this power supply on. And we have 350 microamps. So let's turn this up. And so far so good. It looks like they are reading the same. So that's 210 microamps, and let's turn it up to 1 milliamp. Oops, a little too much. So that should be 1 milliamp right there. It's a little bit out. It's a little bit out on the scale. But then so is this one. But I would trust this one before I trust this one. Yeah, 50%. Let's see, let's get 500 microamps. It's showing a little high, but they're in unison, so that's good. So this will substitute for this because they both have the same same deflection on the same currents. So this will be a good fix, I think. Let's shut this all off. I'll get this meter installed, and we'll put this one aside, even though it's working. I am replacing it because we all know this is the reason why. Okay. Alright, so here it is after I did a little bit of work. I installed the meter with the 100 microfarad cap. This is 6.3 volt. I replaced 6 resistors. Yeah, 6 resistors because they're all out of tolerance. These are 10% tolerance and these are way out. So I replaced a bunch. I used a carbon comp just to keep the look the same. Replaced, how many here? 3 here, and I replaced 3 here. So that's all good. Put a new power cord on, or a different power cord, not a new one. And that's pretty much it. I think these 2 resistors are out of tolerance too, but I don't know if I want to change those. I'll see how it works. Did a bit of deoxing on the switches and cleaned up the front panel, so it looks a little better now. You can see that. It looks with the new meter on it. It's kind of overpowering, a little too big. And I'm hoping these tubes fit. This one might be a challenge. These ones should fit. but it looks a lot better now. And cleaned up the knobs. Everything's looking good. So I'm pretty much ready just to put it back together and give it a test. Pretty much the last thing I need to do is I need to go through all these sockets and clean them and retighten them. Now these are just filthy inside here. You can see the dirt that's piled up in some of these. It's gross. Yeah, I need to get some of those dental brushes. They have a little, they're almost like a toothpick, but they have a brush on one end. And then I can go through and I can scrub each one of these contacts with some cleaner and flush them all out, and then retighten them. Because some of these, pretty sure they would benefit from a clean and a retorquing. And then, I don't know what to do with this thing. What should I do with this? This is filthy, and it's got that, that vinyl. Somebody went to great lengths to camouflage this or cover it up. And if I peel it off, I have a gray, a dark gray, it's kind of cloth, but it's got a vinyl coating on it as well. You can see it underneath. I'm just wondering if this thing was stolen. Maybe somebody tried to camouflage it. Maybe that's why they did it. Let's pull this off. Get rid of this. Let's see what's under here. Oops, see, like it pulls off. And pulling off this stuff doesn't make it better. It makes it almost like worse. Let's cut this. If it was from a school or something, you would see it painted with ID identification, but I don't see anything here. It's actually not a bad finish. It's just kind of gross with that glue on it. I definitely don't like this wood, this fake wood. I think it's all gonna come off. Another thing I could do is I could completely strip it and then paint the box. Look at this. Ugh. Yeah, I think I'm going to strip all that off. It's still a little beat up, and the rust, nothing I can do about the rust on the hinges. See, it's got that leather grain. It's a cloth, but it's got a leather grain to it, and the whole thing's wrapped in it, which is a nice finish. Kind of like that. Okay, I went through and I cleaned a lot of the sockets, so I cleaned all the sockets actually. But what I used, I found these little dental pick things at the drugstore, and I used them with contact cleaner, this stuff here. Non-flammable contact cleaner. I'm not impressed with this stuff. It was stinking up the house. So I took it outside, and main ingredient, this is, what is this again? Tetrachloroethylene, and carbon dioxide as propellant. So, yeah, it's a pretty volatile solvent for organics. And what I do is I spray some in, and then I would scrub it with this dental thing, and then spray it again to flush it out, and scrub it again, and then blow it out with compressed air. And they're not too bad. Some of them are still a little dirty, but it's mostly corrosion now. I can see the white corrosion. I'm assuming these are tin plated, but they look a lot better now. And a lot of garbage came out. Look at how this rag, pretty much all the staining and stuff was from these sockets, pins. So yeah. I also ran into a problem with the solvent. I got some on the meter face, and it started dissolving the plastic, and it damaged it before I got hold of this and stopped it. And it was also damaging the knobs. I can see they're all coarse now from being dissolved with the solvent. I didn't realize that solvent was poor choice. Anyways, I'll finish cleaning this up. I think we're ready to do a final test. So I pulled off that cheesy wood grain, that fake wood grain MacTac, that vinyl wrap that was on here that somebody did. And I gotta tell you, I like the looks of the case a lot more now. Except it's all covered with this sticky brown, I don't know, 50 or 60-year-old adhesive that's half of it's turned to petrified and then half of it's still. But I think I have a plan. I'm going to clean this off with that tetrachloroethylene, and that seems to be working at removing this stuff. So I'm going to go outside and sit in the sun and try cleaning this up. So check this out. I put about an hour's worth of work into this yesterday, and I cleaned it up, and it looks a hell of a lot better than when I did, but it still has some glue residue. I couldn't get this stuff to come off. It's pretty much petrified at this point, so I'm just going to leave it alone. It kind of adds to the patina of it, and yeah, it's pretty rough looking, but it looks a lot better than with that crappy old MacTac that they put on there. I still have a little bit of loose. See, this is a fabric. It's a fabric coating or covering, and I'll have to glue some of this back down. But I'm happy with this. Looks a lot better. So now I just need to put it together. For the meter, I am going to pull out another. I got several of these. I buy them on AliExpress, and they're really not that expensive. They're like $10 each. So I'll just take the cover off a new meter and put it on my damaged one that I have here. Really wasn't happy about that either. I could probably try sanding and polishing that, but it'd be probably more work than what it's worth. I can just replace the cover. And we'll put it all back together. I still need to spend about 5-10 minutes and adjust all these contacts here. I just want to like tighten them up a bit and give them a little better chance of making contact. So I'll go through and I'll do all these contacts, and then we'll put it together and we'll get testing going. Alright, so we got everything back together again and we're ready to use this thing. And this transporting you into the future. This radio is in an upcoming video. This is just a table radio, and we'll go through and we'll test each of these tubes just to make sure they're good. I have a feeling they're all good, but why not? We got the tester now, so let's test it. So we'll pull out the first one here. This one is a 35, what is this? 35W4. Okay, so what I'll do is I'll set this up and then we'll come back. Now this socket is still really loose, so you have to play with it. Actually, the tube's sitting on an angle right now, so that's what makes best contact. But I'm just going to hold down the quality button. We should be able to see this rise and start to give us emissions test as soon as it heats up. And I do have filament, I think. No, I don't have it at the correct voltage. Okay, there is the correct voltage. Gotta be careful with this, because if you forget it in a higher range, filament voltage range, and then you plug another tube in, like a 12 volt tube in a 35 volt, filament is going to pop the filament in it. So this one's good. Tests 100%. This is the rectifier for the radio. This is a 35W, what was it again? 35W4. Okay, so let's grab another one. Here's a 50B5. This is the audio output tube. And it's another high power tube. Let's see here. It's got, I think it's only got, oh, maybe it's got 2 elements. I'm not sure. Let's get this set up and then we'll. Okay, 50B5. Let's see how this one. This is probably going to be the weakest one, if any, of the tubes. It has the most heat. And I probably expect that capacitor was bad, so it might have damaged the tube. Let's just see what comes up here. So we're taking its sweet time heating up. It's drawing about 15 watts or so for the filament. And this one's up at 100% too. I don't know if these numbers are relevant to anything other than a percentage. This line here where it says diode's okay, that's for rectifiers. So I guess if it goes over that line, we're okay. But so this one tests fine. Put it back. So this is a 12BE6. So let's give this a try. Socket 12. Watch this one come up. This one came up rather quickly. Okay, that one's good. Let's go to the next one. Okay, this is a 12AT6, and it's listed twice in my book, so I guess it has two elements. You have to test each one independently. So let's put this in first, and we'll try the first section. It's not as enthusiastic as the other ones, but it's still doing not bad. Around the 60% mark. That's okay. %65 or so. Okay, the second component. I need to switch this around, and this should be up here. So that would test good as well. It's around 90%. It's good. Our last one's the 12BA6 7 F1A socket 12. Isn't this just exciting to watch videos of tubes being tested? I don't know, it's amazing. The excitement is just probably overwhelming for some. No, I just wanted to make sure, you know, prove the point that this does work, and it's fully functioning now if I can get the socket connections. But yeah, it's going to be a nice addition to my arsenal. You know, at least I have something now I can stick a tube in to test if it has emissions or not. Before I had nothing, and I just had to rely on intuition on if the tube was good or bad. But you know, this would be a good piece of kit to have around. It's nice and small, and you know, it's easy to use. It's somewhat dated, somewhat limited in what it can do, but you know, I think it's going to be a good asset to what my my workbench here. So that one's good too. So we're all done. All right, so take care. Thanks again for watching. That's it for this one. We'll see you in the next one. Take it easy.